Hello guys, welcome to this video. So today we'll be doing this problem. This was a problem from the Stanford Mathematics Tournament and it was a pretty easy problem. I would say it was of the JEE mains level. So of course it should help us understand a few things because this kind of problems have also been seen in JEE papers. So it's saying that cot of summation n equals to 1 to 23 cot inverse of 1 plus then again a summation k equals to 1 to n 2k. Now think this problem might seem a little complicated because of these two summations and the cot inverse, but you just have to follow the steps. So first of all, we would start from the innermost portion. So k equals to 1 to n 2k, right? Now 2 is just a constant. You know that k equals to 1 to n k is nothing but the sum of first n natural numbers, which is n into n plus 1 by 2. So this whole thing can be written as cot of summation n equals to 1 to 23 cot inverse of 1 plus 2 times n into n plus 1 by 2. Cancel off the 2's and you get 1 plus n square plus n. This would mean we simply have cot of n equals to 1 to 23. Now 1 plus n square plus n, since it's cot inverse, I can simply write it as tan inverse of 1 by n square plus n plus 1. Right? Now again, write this as cot of n equals to 1 to 23. Now, tan inverse of this can simply be written as tan inverse of n plus 1 minus n. Write this as the numerator, which is basically 1, and write the denominator as 1 in plus n into n plus 1. If you remember, this is the formula for tan inverse a by b, correct? So this would simply give you cot of summation n equals to 1 to 23 tan inverse of n plus 1 minus tan inverse of n. Now, this would simply give you cot of, now this would obviously cancel off and you would be left with tan inverse of 24 minus tan inverse of 1. You can simply calculate this and make this as a cot, which would simply give you cot inverse of 25 by 23. The answer is 25 by 23, and therefore we have completed the problem. It was an easy problem. So the problem said 0 to infinity e to the power minus 2x sine 3x by x dx. In your boards and in your J's, you have seen problems like e to the power minus ax into sine of bx. It's a pretty standard integration formula which is done using integration by parts twice. This is very different because we have a extra by x in the denominator, which is going to make things hard for us. But not to worry, what we are going to do is this. We are first going to define a function like f of a, which looks something like this. This is the famous trick, which is also known as Feynman's trick of integration under the differentiation sign. So we are going to differentiate a function like this, okay, dx. Now, this function is convergent, and by Feynman's theorem, you can actually differentiate it inside. It is proved that you can do it, and obviously a is greater than 0 here. That must be mentioned because otherwise the integral diverges. If you differentiate with respect to a, you simply get minus 0 to infinity. Now understand, differentiating with respect to a means e to the power minus ax, where x acts as a constant. So basically minus x would be out because of chain rule, and that x will cancel off itself with this x. So you will be simply left with e to the power minus ax sine 3x dx. It's a pretty standard integral. You must have done it. I will not do it here. It simply means your value is 3 by a square plus 9. Okay. Now this is your value basically. Now understand, f of 0, the value here, if you basically were to find f of 0, which is also actually you can simply do it a greater than equal to 0. F of 0 is 0 to infinity sine of x by x sine 3x by x dx. It's a pretty standard integral. You can see on the top right, a variant of this also has been done there. This is equals to pi by 2. What we require is f of 2, correct? We require f of 2. Now, from this equation, integrate both sides from 0 to 2, f dash a dA, and by fundamental theorem of integral calculus, this is nothing but f of 2 minus f of 0. And f of 0 is how much? F of 2 is what we need, and f of 0 is pi by 2. Therefore, the value of f of 2 is nothing but pi by 2 plus 0 to 2 f dash a dA. So simply I'm taking this value to this side and finding out the value of f of 2. Now you also know f dash t is nothing but minus of this. So pi by 2 minus 0 to 2 3 by a square plus 3 square dA. Now this is again nothing but pi by 2 minus. Now you can simply write 3 by 3 tan inverse of a by 3 from 2 to 0. This simply gives you pi by 2 minus tan inverse of 2 by 3, which is cot inverse of 2 by 3, or simply tan inverse of 3 by 2, and thus you are done with the answer. Now, just a note, to evaluate this integral, you can simply use sine 3x as e to the power I 3x and then compute this integral thinking of I as a constant and then simply equate the real and imaginary parts and find out the imaginary part. Or you can simply do integration by parts twice. So yeah, this is the integral, and okay, this was an MIT integration B finals problem. So yes, it is indeed tough. The solution may look simple, but yeah, calculating and understanding and then formulating this function is not really as easy as it seems. Okay.